Okay, let's dive right into this explainer. We've got an absolute engineering mystery on our hands. It all kicked off when a Chinese research vessel quietly anchored over this unmarked coordinate in the South China Sea. Just sat there for 11 days. No press release, no official explanation whatsoever. And by the time a Philippine Coast Guard aircraft actually flew over to check it out, the ship was already gone. But what we're unpacking today isn't about what that ship took away. It's about the massive, completely silent footprint it left behind, and how it is literally rewriting the future of global AI infrastructure.
What that vessel left behind was entirely invisible from the surface, mainly because it was dropped 35 meters underwater. We're talking about a massive, highly pressurized steel and titanium structure weighing 1,300 tons. That's roughly the weight of about 3 jumbo jets. Now, for years, Western analysts have monitored activity in the South China Sea, constantly expecting to see surface military bases or missile batteries. But they were looking at the wrong half of the picture. This 1,300-ton giant isn't a weapons platform at all. It is the very first node of an $879 million undersea computing grid.
So you gotta ask yourself, and keep this central question in mind as we go through this. Why on earth would anyone take delicate, hyper-advanced AI servers, the exact hardware reshaping our global economy, and intentionally drop them onto the harsh, unforgiving ocean floor? Does sinking our most critical infrastructure make it invincible, or does it leave it permanently vulnerable? Well, to understand this radical pivot, we really have to look at what's happening up on dry land first.
Section 1. The terrestrial bottleneck, escaping the heat.
Look, when you're querying an AI model or streaming a video, you probably aren't thinking about the ocean. But every single query runs through a massive server farm on land, and those servers generate intense, concentrated heat. It's actually kind of shocking. Cooling alone accounts for a staggering 40% of every data center's total electricity consumption. Nearly half the power used to train global AI models isn't even spent on thinking. It's wasted entirely on just preventing a physical meltdown.
The environmental strain of terrestrial cooling is just becoming brutal. It demands millions of gallons of purified fresh water and these massive, power-hungry AC systems. But look at the subsea alternative. By placing the data center underwater, you achieve passive thermal exchange. Cold seawater naturally circulates around the structure, it absorbs the heat, and it disperses it right into the coastal currents. There are no active cooling fans inside, no massive chiller plants, and most importantly, zero freshwater consumption. Now, Western firms like Microsoft actually proved this physics worked a few years ago with Project Natick, but they walked away due to commercial and regulatory hurdles. China, however, did not. Which brings us to the immense physical challenges of actually building this thing.
Section 2. Engineering the titanium hull, surviving the deep.
So, how exactly do you put standard data center hardware into literally one of the harshest environments on Earth? Well, the engineering breakthrough happened when they stopped treating the data center like a traditional building and started treating it like a deep-water, military-grade submarine. They had to construct a highly specialized pressure hull.
The specs on this are just awe-inspiring. At 35 meters deep, the ocean is exerting over 50 pounds of force per square inch on every single seal and weld. So they built this massive cylindrical titanium alloy hull. If you laid this thing on its side in a city street, it would block 4 entire intersections. But dropping metal into the ocean creates a massive biological problem: marine life. A thick layer of barnacles and algae actually acts as thermal insulation, which would literally cook the servers from the outside in, basically a very expensive seafood bake. To solve this, engineers coated the hull with specialized deep-sea naval anti-fouling tech. We're talking the exact same chemical defenses used on military submarines, paired with automated underwater drones that constantly clean the exterior. But the real magic? That happens inside the cylinder.
Section 3. The nitrogen gas solution, eliminating fire and rust. Okay, so the absolute deadliest threat to any remote data center is an electrical fire. But the crucial point here relies on a simple law of physics. You cannot have a fire without oxygen. By completely stripping the interior of all oxygen before sealing the module, engineers took the risk of an electrical fire and mathematically dropped it down to absolute zero.
Instead of oxygen, the cabin is entirely flooded with 100% inert nitrogen gas. This is an absolute game changer. Why? Because without oxygen or atmospheric humidity inside that tank, standard server hardware simply stops degrading. The corrosion rate basically flatlines to zero. And because it's completely isolated from atmospheric dust, human air, and seasonal temperature swings, the hardware failure rate inside these nitrogen-filled modules is projected to be just 1/8 that of an equivalent land-based facility. But this isn't just about protecting the servers themselves. It's about how those servers talk to the rest of the world.
Section 4.
Bypassing telecom bottlenecks. The latency war.
Let's be real. Terrestrial telecom is incredibly vulnerable. A commercial LAN cable gets accidentally severed by a construction backhoe, and boom, entire regions experience network slowdowns. Plus, every single relay point across thousands of inland miles adds milliseconds of latency. But with this undersea architecture, engineers are plowing heavy synthetic armored cables deep into seabed trenches. Because they're buried beneath tons of compacted sand, the risk of accidental severance from anchors or severe weather approaches zero. This creates a dedicated ultra-low latency network that completely bypasses vulnerable land-based telecommunications bottlenecks, which leads directly to exactly where they're deciding to place these nodes.
Section 5. The Coastal Megacity Advantage. Location is everything.
Geography is really the secret sauce here. They are strategically dropping these computing nodes on the continental shelf, literally right off the coast of their primary economic engines, cities like Shanghai, Shenzhen, and Guangzhou. For things like high-frequency financial trading or real-time AI inference, a delay of even 20 milliseconds is an absolute deal-breaker. A fraction of a second delay can literally cause an autonomous vehicle to crash. By placing the data centers just off the coast, they eliminate that latency entirely, and they do it without consuming a single square meter of incredibly scarce, premium coastal real estate. And it gets even better. They're positioning these hubs directly beneath massive offshore wind farms, so the power flows straight down the turbine tower into the subsea cables, no transmission loss, no grid dependency. It's a completely closed-loop, zero-carbon AI infrastructure. But you might be wondering, surely things still break, right?
Section 6. Aerospace Level Retrieval. Fixing the unreachable. So how on earth do you fix a broken server when human divers can't survive the pressure, let alone a crushed nitrogen environment? The answer is aerospace-level precision. When a fault is detected, network traffic automatically reroutes to neighboring modules, so the system never blinks. Then, robotic submarines zip down and detach the external power cables. An internal ballast system slowly purges seawater from the buoyancy tanks, allowing this massive 1,300-ton structure to ascend. And it does this at a strictly controlled rate of just 1 meter per minute to completely prevent thermal shock and structural warping. Once it hits the surface, a mobile dry dock pops the seal, swaps the hardware, repressurizes it with nitrogen, and drops it right back down. The whole shebang takes less than 48 hours. And they are moving at blistering speed. While Western subsea deployment timelines can stretch out for nearly a decade just navigating environmental reviews and zoning laws, this state-backed project went from a basic geological survey to live commercial data processing in under 36 months. In 2023, they dropped the first module. By 2025, they're deploying a heavier AI-specific module, hitting 7,000 deep learning queries per second. That's the equivalent of 30,000 high-end workstations humming away in pitch-black water. By 2028, they plan to scale up to 100 massive modules off the Hainan coast, and by 2030, they aim to integrate these undersea nodes directly with a low-Earth satellite network, essentially creating a global communications loop entirely outside traditional land-based internet architecture, which brings us to the ultimate conclusion of this massive shift.
Section 7. The future of AI. Sinking the cloud.
What we're witnessing right now is the physical reality of the cloud being permanently dismantled. The old concept of the cloud just hovering in some air-conditioned desert warehouse, that's fading fast. Whether it's the phone you charged last night or those massive autonomous vehicle fleets in Shenzhen generating 4,000 gigabytes of data every 24 hours, the raw computing power behind all of it is migrating to the ocean floor. And it leaves us with this final, honestly startling thought to chew on. Is the infrastructure required to run the future of human intelligence permanently migrating into an alien, high-pressure environment where humans cannot even survive? One thing is for sure, the nation that gets there first, at scale, won't just lead the AI race, they're going to own the very foundation it's built upon.